Okay, on we go to problem 8 from Superquiz 1. Here we are given two derivatives, and the thing we're differentiating are functions defined with an integral. So you can see, for instance, in the first one, we're going to integrate a function, sine of t over e to the t squared, which is pretty complicated. And we want to integrate it starting from t equals 1 up to, well, some variable amount, call it x. So obviously, this won't give you a specific value unless you know what x is. But once you know what x is, it gives you some value. So this is a function of x, and we can take the derivative. Now, the first fundamental theorem of calculus, right, which they cite here in the instructions, tells you if you define a function in the way we did here and then take the derivative, it's very easy to take this derivative. You simply evaluate this function at the variable power, or the variable input. So this would just become sine of x over e to the x squared. Right? Period. No muss, no fuss. All right. In part B, we have a little more subtle of an issue because now we're integrating not from a constant to a variable, but actually from a variable to a variable. So the way we sort this out is by breaking this up at a constant. So we'll take, say, an integral from x cubed to, well, let's just stop it at, say, 0. Okay, so then we have sine of t over e to the t squared dt. And then we'll integrate it from 0 to x. So this utilizes a very reasonable property of accumulation, namely if you accumulate starting from one point to another point, you can break it up, right, by choosing some point, say, in the middle, going from the first point to the middle, and then going from the middle to the end point. Now, another part of the fundamental theorem, of course, is that this constant is supposed to be on the bottom, like it was in part A. But that's easy enough to take care of. If we put a negative sign in front of our integral, it allows us to switch the order of integration. So we can go from 0 to x cubed. Okay, so now both of these integrals are set up for using the fundamental theorem of calculus. Okay, now we do have to make a small observation for the first one. Which is, okay, well, first when we take the derivative, the negative can come out. But now this is no longer a function of x, but of x cubed. So since we're taking a derivative with respect to x of something who's evaluated at x cubed, we have to use the chain rule. So first, we evaluate at x cubed rather than x. So this will be x cubed squared. But then we have to multiply by the derivative of x cubed, which is 3x squared. Now, luckily, the second one, it's essentially the first problem, only it starts at 0 instead of 1, but the fundamental theorem of calculus, which, by the way, right, that's what we're using here, it doesn't care which number you start at. So this is still sine of x over e to the x squared. Okay, and that's how we compute the derivatives.